Thank you for joining us today. My name is John Ugland and I'm a Senior Product Manager for NRG Systems. Today we're going to be talking about beyond the turbine, non-wind applications for NRG's Bat Deterrent System. So I've been involved in the wind industry for most of my professional career, and I've been involved in bats and wind for the last 2.5 years. And today we're going to be talking about a little bit about NRG's Bat Deterrent System that was designed for the wind industry, and then I'm going to focus on applications beyond the wind industry. So I thought I'd start things off by offering an overview of the NRG Bat Deterrent System as it was designed for wind. I want to make sure we're all on the same page as to why bats are important and worth protecting. We'll look at the success story outside of the wind industry, so on a bridge, and then I want to look at perhaps some hypothetical alternatives. NRG does a lot of webinars in this, and most of our webinars are about the great things we've done. And in this case, we have done some absolutely great things, but I'm actually looking at almost like a crowdsourcing, because I truly believe there are applications and opportunities outside of the wind industry that this Bat Deterrent product can really work well. So just to level set everybody, I thought I'd share some of my favorite bat facts and why NRG is doing what we're doing. There are over 1,100 species worldwide, which makes up a quarter of all mammals, and I think that's pretty impressive. So there's a lot of bats exist on our planet, and it's the only mammal to truly fly. And I think the most important aspect of bats is they often consume their body weight in insects every night, primarily mosquitoes, or in many cases mosquitoes. Not sure about you, but that's one of my least favorite insects. However, globally, many bat species are threatened or endangered. And the human-bat conflict continues to persist and is often really a driver for a lot of the reasons behind their endangered status or even some species going extinct. And that's primarily humans moving into their spaces that bats would normally consider their natural habitat, and humans trying to encroach and take over that. And specifically in North America, the white nose syndrome has really decimated bat populations. In some cases, and this affects primarily cave-dwelling bats, but in some cases taking local populations down to less than 90% of their original population before the white nose syndrome set in. And white nose syndrome has been spreading across the United States. It was first picked up, I think, around 2006 on the East Coast. And this graphic here is a little bit aged, but it's definitely progressing east to west across the North America, and is expected to impact pretty much all cave-dwelling bats in North America. So I wanted to talk a little bit about the initial development of NRG's Bat Deterrent System. And like I said earlier, we did the genesis of this product really was the wind industry. So in the early 2000s, the Bats and Wind Energy Cooperative was established to study mortality of bats on wind projects. This image on the lower right, provided by Wildlife Imaging Systems, is a thermal composite image of a bat just orbiting around, in this case, behind a wind turbine, which is relatively safe. But I would say scientists still don't truly understand exactly why bats seem to be attracted or come to wind turbines, but the industry has definitely seen that as an uptick. And so in the early 2000s, the BOC was established to study this. In 2009 and 2010 timeframe, the Wind Energy Technology Office, which is part of the Department of Energy, funded a study of Bat Conservation International and Deaton Engineering to look at an ultrasonic system that could deter bats from wind turbines. So the image there on the top right is a prototype of theirs mounted on a wind turbine, and that small-scale study showed that that system was successful. So around 2014, NRG entered the picture, really to take on product development activities to design for the wind turbine environment. So the image there on the bottom right is the system as it's designed today. NRG has a long history, 40 years in fact, of designing products that are designed to be installed and used 24/7 outside. And so in this case, we applied those same design principles to come up with a system that we could mount on top of a wind turbine, and that it could operate for many, many years in the field. In 2015, the Wind Energy Technology Office funded a collaboration study between BCI and NRG Systems to test that first prototype system at an operational wind farm. So this is the last slide I have on the wind industry, but I really like to share this slide and this image, and I talk about it a lot, because to me it really is a great example of the benefit of BAT to the wind industry and NRG's Bat Deterrent System back to bats. So this is a very good example of a typical Midwestern wind farm with corns and soybeans, and the Bat Deterrent System is protecting the bats from the rotor swept zone of the wind turbine. But the bats are otherwise free to maintain their normal lifestyle, foraging for insects and providing a very important natural pest control there underneath the wind turbines. NRG at this point, since 2019, has deployed almost 1 gigawatt of Bat Deterrent systems to wind turbines. So that's quite a few wind projects globally that are now seeing bats being protected from the wind turbines. We've installed these in the United States, several projects in the United States, including Hawaii and the Midwest and Texas, several parts of Canada, France. We have a couple of projects in South Africa, and most recently the Philippines. I think now would be a good time to show a little bit about how the deterrent system works. The idea behind this is bats use echolocation to navigate and hunt, so they send out a outgoing pulse of high frequency sound. It can be as high as 100 decibels, in some cases even higher. That sound will reach a target in front of the bat, and then it's going to bounce back to the bat. So that's called the echo. And so the bat is listening for that echo, and from that, the sound that's returned to the bat is able to paint a picture of the airspace in front of it. The way the NRG Bat Deterrent System works is it's broadcasting sound in a similar frequency range and sound pressure level as the bat's listening for. So all of a sudden, as the bat enters the airspace that's filled with the ultrasound from the Bat Deterrent System, they've all of a sudden found an airspace that's really unnavigable. They're no longer able to hear the return echoes of their pulse, nor really anything else around them. My favorite analogy is kind of like driving to the rising sun. I've had this happen to me a few times, and as you're going down the highway, and the sun's just blinding you, you really just want to turn around and go a different direction. Why go beyond wind? So NRG has had a really good track record in the wind industry space for this Bat Deterrent System. But we believe there's opportunity outside of wind, and in fact, a lot of this has actually come to us from either consultants or friends of NRG that are involved in other industries. And I think the natural next step is construction and bridges specifically. And why bridges, one might ask? Well, bridges are actually a really good bat habitat. They're well protected. They usually have small crevices. They're typically high up off the ground, so it's really easy for a bat to ingress or egress. And they're often over waterways or flyways where a bat may already be planning to feed. So that's great. But why are bridges an issue? So specifically in the United States, I'll say in this case, any bridge that may have a species of bat that's protected either federally or locally, all of a sudden the construction or repair of that bridge needs to be managed around the bat itself. So you have to inspect the bridge and understand where the bats are, come up with a mitigation plan, and do your construction around the presence of the bats, meaning you may need to delay your construction start time after the bats have left for the season, or come up with plans to blockade the structure prior to bats even entering for the season. So that's relatively easy to do today, but it does mean your seasons are really dependent on bat activity and having these physical barriers in place. The bridge infrastructure in the United States, as many of us know, is perhaps lacking. There's currently over 45,000 bridges that are structurally deficient or in poor condition, and close to 300,000 bridges that are in fair condition that could require work. So we're talking about a lot of bridges in the United States alone. And if we had the ability to repair them or work on them and remove at least one variable of bats, I think there's an opportunity there to apply a deterrent technology and keep the bats safe. So this is an example of a bridge application that was done several years ago. This image on the left is an expansion joint between two bridge sections. And you'll see staining there. That's from the bats, so they live up inside that crack. The system, as deployed, is a controller that runs off of like a 110, either a remote power supply or like a generator or a battery and solar. And then a series of these speakers that are deployed, in this case on tripods, and they're pointed up at the girders of the bridge. And the speakers are arranged such that the sound is focused at that span. Prior to the start of the study, a manual count of the bats in that expansion joint is done by using a borescope. So a borescope is a tiny camera, in this case on a long pole. You stick the pole up in there and you can get an image of the bats and count the number of them that are there. At night, after the bats have left for the evening, the deterrents are turned on. So the intent is to not use the deterrent system to actually force them to leave. We're not trying to blast them with sound. We want it so that when the bats come back after their forage, they've found that they can no longer get back into their roost, and so they're going to go somewhere else. In this particular study, it was done over 3 nights, and you'll see on the bottom left here, the deterrent locations were placed around this single span, and bat counts were done on a few spans of the bridge. So we had 147 bats in this original span. The deterrents were turned on around midnight, so after the bats had left for the night. And the next morning, a count was done, and there was a single bat. We don't know if that bat had never left or if it somehow snuck in, but there was one bat, and you see the rest of the bats moved farther down the bridge. The system was run again the following night, same scenario, so it came on after midnight, and it ran through sunrise. You see now no bats in that span. All the bats had moved farther down the bridge. So from a sort of a maintenance strategy point of view, there's a couple different ways you could think about doing this. If you wanted to maybe you just had to do some work here, you could apply this technology for a few nights and make sure the bats are gone. You could apply this technology and then do some more permanent like crack filling so that the bats can't get back in and move the equipment down the line. There's a lot of ways you could actually use this to manage a bridge repair. So here we enter the sort of the crowdsourcing portion of our webinar today. I want to start by showing off these images on the far right. So these are composite images, also courtesy of Wildlife Imaging Systems, that show a deterrent test. So this is not a commercial application, but just testing units on a waterway. The image on the top right shows bats. This is a composite image of maybe, I think it's 5 or 10 minutes. So lots of bats flying around the waterway. The image on the bottom when the deterrents are on shows virtually no bats. I think I see one, perhaps that's maybe high. The streaks that are going across the top there are actually high-flying birds, so probably migrating birds. Just a really great image showing truly the effectiveness of the deterrent system. So what else? Again, I think white nose syndrome has really put a significant amount of pressure on bats and those working around them. I think it lends us to think what other places can we apply this technology. I've put here a list of inbound requests that I've seen. I would, again, love to get feedback from the audience here on applications that they think they may make sense. But things like mining, military and historic building remediation, so we have bats that are in buildings, and we need to either tear the building down, or if it's a historic building, just repair it and get it back up to speed. Maybe you need the bats gone while you do that, or seal it up so that they're not using part of that building as a roost. Outside of bridge construction, I've heard of perhaps the need for keeping bats at bay during a construction phase, or even in a new building where bats may enter the building while the construction is happening, and you don't want them to be trapped in there in the internal part of the building. And even road construction. So if there's road construction near bat roost or a cave, you may want to deploy a temporary setup to keep the bats out of the cave during that construction. Covered arenas or industrial facilities, in many cases fans are not bat fans, and this could be a form of humane pest control. I do want to be careful, though. It's not NRG's goal to have this as a product that's, I don't want bats in my backyard because I don't like them, so let's put this up. This really is, we intend the purpose of this to really improve the human-bat interaction and allow bats to be humanely relocated or just kept from a place that they're not invited. And the last one I've explored is vegetation management, and that sounds kind of funny, but we were in a scenario this spring talking with a utility where they needed to remove some trees for a construction project on a substation. But prior to doing that, they had to have permits to take the trees down because they were trees, potential bat roosting trees. This was all happening before the bats had arrived for the season, but they were concerned that they might not get their permits in time. So we actually came up with a plan to deploy the deterrents around the trees prior to the arrival of the bats for the season, so that we could keep them, so it would essentially make the tree invisible to the bats, and the bats would not choose that as a roost, and they would roost elsewhere, and so that by the time the permitting happened, they would actually be able to remove the trees without having to manage the bats. Ultimately, they got the permits done in time, so we didn't actually have to go through with this, but it was a really interesting application of this product. So to tie things up, the NRG Bat Deterrent System now is deployed on close to 1 gigawatt of wind turbines, which I think is really great for something like this. We have actually participated, or at least supplied equipment to several successful bridge projects in the U.S. This image on the right, provided by ICF, is a floating bat barge that they used in Georgia. So there's the speakers here running on a generator. This bridge is low enough close to the water that it made sense to just put the speakers there in the middle and protect the bats that way. And I believe there is strong potential for the mitigation of the bat-human conflict in looking at other applications well beyond the wind industry and even beyond bridges and things like that. With that, I want to thank you for coming today. Please connect with NRG for any questions or comments, or even any ideas you have where this might be a successful product. I'd really love to hear your ideas. Thanks again. My name is John Ugland. Have a great day. Bye-bye.